This is part 4 of the log videos. The surprise fourth part you didn't know was coming. We're going to talk about the product property, the quotient property, and the power property. So the product property says log base m of a times b equals log base m of a plus log base m of b. And so it allows us to add logs that have the same base, and so they can become a single log expression. So an example of that would be log base 5 of 3 plus log base 5 of 10 equals log base 5 of 30. We could try to simplify that by thinking about 5 to the power of what gives us 30, and we'd know that it was a little bit more than 2, so maybe I'd say like about 2.2. The quotient property says log base m of a divided by b equals log base m of a minus log base m of b. And so this is similar in a lot of ways. Again, we are able to combine two log expressions that have the same base into a single log expression. An example would be log base 7 of 52 minus log base 7 of 2 equals log base 7 of 52 divided by 2, which is 26. We could ask ourselves 7 to the power of what gives us 26, and we know that it's less than 2, but greater than 1, so we could estimate that x is, about 1.4, something like that. The last one is the power property, which says that log base m of b to the power of x is equivalent to x times log base m of b. An example would be 3 times log base 2 of 5 is equal to log base 2 of 5 cubed, and then we could go ahead and simplify from there. So the first example is log base 2 of x minus log base 2 of 3 equals 4. And so I see that I have two log expressions with the same base being subtracted, and so I'm going to use the quotient property to combine the left side of my equation into a single term. Log base 2 of x divided by 3 equals 4. And then I'm going to use the definition of a logarithm to rewrite this in exponent form. So this is saying 2 to the power of 4 gives me a value of x minus 3. We know that 2 to the 4th is 16. And now I've got x divided by 3 equals 16, so when I multiply by 3 on both sides, I see that x equals 48, and that's my solution. My second example is going to use the product property. So we've got log of x plus log of x plus 2, x plus 21 equals 2. So I'm going to use the product property to combine my two log expressions. They have the same base, and remember that if there's no base written, it means base 10. So the left side can become log of x times x plus 21 equals 2. I can use the distributive property to say that that's log of x squared plus 21x equals 2. And now I'm going to rewrite in exponent form. 10 to the power of 2 equals x squared plus 21. 10 squared is 100. So I've got 100 equals x squared plus 21. And this is a quadratic equation that I need to solve, which I'm going to do, or I'm going to try to do using the zero product property. So I'll set the left side equal to 0 and see if this is factorable. I'm recognizing that x plus 25 times x minus 4 will give me the right expression. So I know that x equals negative 25, and x equals positive 4. There's one interesting thing here. We got a negative x value as a solution, but if we think about the log of negative 25, that's actually not defined. And if you watch the video about graphing logs, you'll see that there's a vertical asymptote at x equals 0, which means we don't have x inputs that are less than 0. That has to do with the fact that it's the inverse of an exponential function, which doesn't have outputs that are less than 0. So x minus 25 is an extraneous solution, and x equals 4 is the only actual solution that we would find if we did this problem graphically. And my last example is one that uses the power property and the quotient property. So 2 log base 4 of x minus log base 4 of 3 equals 2. I'm going to use the power property to put that coefficient of 2 in the exponent. Log base 4 of x squared minus log base 4 of 3 equals 2. And then I can use the quotient property to get log base 4 of x squared divided by 3 equals 2. Now I can rewrite in exponent form. 4 squared equals x squared divided by 3. 4 squared is 16. So 16 equals x squared divided by 3. Multiply by 3 on both sides to get 48 equals x squared. And so x equals plus or minus the square root of 48. Remember that we can't have log of a negative number. So my only solution is x equals the square root of 48. X equals negative the square root of 48 would be extraneous. So make sure you do the practice problems and let me know when you're ready for a retake.